The 3 points plotted below are on the graph of y is equal to b to the x power. Based only on these 3 points, plot the 3 corresponding points that must be on the graph of y is equal to log base b of x by clicking on the graph. So I've actually copied and pasted this problem on my little scratch pad so I can mark it up a little bit. So what is this first function? This first function is telling us, so x, and this is y is equal to b to the x power. So when x is equal to 0, y is equal to 1. When x is equal to 0, y is equal to 1. That's this point right over here. When x is equal to 1, b to the 1 power, or b to the first power, is equal to 4. Y is equal to 4. So another way of thinking this, y, or 4, is equal to b to the first power. And actually we can deduce then that b must be 4. So that's this point right over there. And then this point is telling us that b to the second power is equal to 16. So when x is equal to 2, b to the second power, y is equal to 16. Now we want to plot the 3 corresponding points on this function. So let me draw another table here. So now it's essentially the inverse function where this is going to be x, and we want to calculate y is equal to log base b of x. And so what are the possibilities here? So what I want to do is let's take these values, because these are essentially inverse functions. Log is the inverse of exponents. So if we take the points 1, 4, 1, 4, and 16, 1, 4, and 16, 1, 4, and 16. So what is y going to be here? Y is going to be log base b of 1. So this is saying what power I need to raise b to get to 1. Well, if we assume that b is non-zero, and that's a reasonable assumption because b to different powers are non-zero, this is going to be 0 for any non-zero b. So this is going to be 0 right there over here. So we have the point 1, comma 0. So it's that point over there. And notice, this point corresponds to this point. We've essentially swapped the x's and y's. And in general, when you're taking an inverse, you're going to reflect over the line y is equal to x. And this is clearly a reflection over that line. Now let's look over here. When x is equal to 4, what is log base b of 4? What is the power I need to raise b to get to 4? Well, we see right over here, b to the first power is equal to 4. We already figured that out. When I take b to the first power is equal to 4. So this right over here is going to be equal to 1. So when x is equal to 4, y is equal to 1. And notice, once again, it is a reflection over the line y is equal to x. And so when x is equal to 16, then y is equal to log base b of 16, the power I need to raise b to get to 16. Well, we already know. If we take b squared, we get to 16. So this is equal to 2. So when x is equal to 16, y is equal to 2. Notice we've essentially just swapped the x and y values for each of these points, which is why this is a reflection over the line y is equal to x. Now let's actually do that on the actual interface. And the whole reason is to give you this appreciation that these are inverse functions of each other. So let's plot the points. So that point corresponded to that point. So x0, y1 corresponds to x1, y0. Here x is 1, y is 4. That corresponds to x4, y1. Here x is 2, y is 16. That corresponds to x16, y is 2. And we got it right.